Hey everyone, just wanted to make a quick video about this game Wordle. Um, kind of taken the internet by storm, and I thought it actually serves as a cool learning opportunity to show users how things work in their browser. Fair warning, this will kind of ruin the game for you, so if you don't want that to happen, I suggest you click away. Or um, if you feel like you can control yourself and are driven by the pursuit of knowledge, continue watching because I'll teach you something. So normally, web applications, whenever they are run, they are made up of a little bit of static content, uh, building blocks called HTML, and um, websites can get behavior basically injected into them via a variety of tools. You can get like animations via things like CSS, but one of the main forms to get behavior into websites is via something called JavaScript. So whenever you load up a page, all of the client side JavaScript that is in charge of the behavior here, you can see in your browser. Um, Now, it's not always easy to see, which is what I'm going to show you, but hopefully after this is over, you can learn how to pick apart a site just in a little bit of a basic way and find what you're looking for. Um, so one interesting thing about this site, uh, there is no those so the behavior that is responsible for choosing the word that you see is not actually fetched by an external resource. That being said, when the page loads, it does a calculation and then gives you a word that is actually stored somewhere in the JavaScript file for this page. So yeah, let me show you how you can find it, and then we can pick apart the code a little bit and play around. So I'm going to press F12 on my keyboard, and that opens up the debugger for Chrome. And then I'm going to navigate over to the Sources tab here. Now the Sources tab kind of shows you the files that you fetch by hitting this page. So if you look at index, you'll see a little bit about what I was talking about. There's some static HTML content. And then at the very bottom, it runs a script called main E65CE0A5, which is bundled together with it right here. And this is the behavioral JavaScript file. So what you see here is something called minified JavaScript. So it's like impossible to read. It's all smashed onto a few lines. And the reason for that is because that is really useful for making your pages as small as possible. So a lot of the times you'll run your pages through some kind of minifier or um, what is effectively like a compiler slash translator, and it'll return you back a smaller file that does the exact same thing as what you coded. It's not really readable, but it does the same thing. So um, one of the cool things about the Chrome debugger is that it allows you to pretty print or format these minified files. Um, the option normally shows up here. It's good at recognizing when it sees stuff like this. But if it's not there, there is this little double bracket at the bottom left-hand corner of the file pane. So if you click that, it actually dumps the file into something that looks readable. Um, so something interesting, like I mentioned, the word served for a given day is not actually fetched from a server. It's located in the page. So a quick way to find it would be to find a 5-letter word. So you can do that with a regular expression, and we'll kind of trim it down a little bit to kind of look for what we're trying to find. So this right here just gives me any 5 letters, A to Z, lowercase, and 5 of them in a row. As you can see, it kind of has a lot of hits. 17,000 or so hits. That's useful. We could use that and scroll through to find the information we're looking for, but if we trim it down a little bit, we can actually have an easier time finding the words that are stored in the page. So these words are likely going to be stored as strings. So if I just tack on a quote to the beginning, that cuts down on my search by a couple thousand words. Now, another way to cut down on this is all of these words are likely going to be placed in a collection of some sorts, and in JavaScript, collections, arrays, always start with a left bracket character. Now, I use left brackets in my regular expression, so I'm going to have to escape the left bracket to actually find the literal character bracket. Now, as you can see, there are 10 matches. So if I just pick through these, I end up finding 2 massive arrays of 5 character strings, and they are all words. So what I'm going to do is I'm just going to copy these off to the side. So just do this, copy, and I'm going to paste them directly in my console, which is a JavaScript runtime environment. So now once I paste those, I have access to those 2 arrays of words. Pretty cool. So I don't know which one is which yet and what exactly they do. So if I turn off the regular expression searcher, I can use each of these arrays to find out where they are used. So if I do TA and a left bracket, that would indicate that I'm indexing that array. I don't find anything. So if I just try LA instead, we see 1 instance of that array being indexed. And it's being returned from a function called DA. So if I look at instances of where DA is called, I actually see something here called e.solution equals DA of e today. And e.today is a new date object. So if I pass DA a date object, I'm going to get today's solution out of it. That's what I interpret. So if we just pick through the DA function, we should be able to understand kind of what's going on here. So DA declares a variable A and a variable S, where S is the result of the function GA of today's date. Conveniently, GA is right below us, and it takes in today's date, and it returns us NA of HA and our current date. Now, you might say, what is HA? Well, if you just go up a few lines, HA is right here, and that is defined as a date hard-coded to be May 19th of 2021, which is, I believe, the day this application was launched. So we send the application launch day and our current date to our function NA, which is up here. So NA takes our launch date and our current date and creates a new variable S from the launch date and creates a new variable T, which is our current date and the set hours function, and we subtract from it the launch date whose set hours is 0. So we can illustrate what the set hours function does real quick. So if I do a new date of today, which is just past January 21st, 2022, and I subtract from it yesterday, or let's do the set hours, excuse me. And I subtract from it January 20th, 2022 set hours, I get this number, which is 86,400,000. That number is not apparently meaningful to us, but I can tell you where that number comes from. That is the number of milliseconds that exist in a day. So I can prove that by saying 60 times 60, which is 60 seconds in a minute, times 60 minutes in an hour, times 24 hours in a day, time, which is 86,400 seconds, times 1,000, which gives us the number of milliseconds in a day. So that function calculates the number of milliseconds and then divides it by the number of milliseconds in a given day, and then rounds that number down. So what that's going to do is that's going to allow us to index or get numbers in incremental chunks from the day that we initially reference. So when this function is called on May 19th, we get 0. When this function is called on May 20th, we get 1, and so on and so forth. That number gets returned back to GA, and GA returns that back to here. So we now have an index, and A is going to be the it's effectively going to always be an index within the range of LA, which is the letters we're choosing from. That's what the modulo function does. It is basically like give me the remainder from division. So this will always give us a number inside our array, and we will always be able to index from within there. So this code alone is responsible for generating the word that you get when you first open the page. That's kind of funny because the first time I recorded this video, I launched the page on Thursday, January 20th, before 12:26, or I launched it right before midnight, and midway through the video, I crossed the plane into January 21st, and I tried to demonstrate that I could get the answer from January 21st, but that answer was incorrect because the answer was already predetermined when I launched the page. But now, since I've launched the page on January 21st, I can demonstrate today's answer. So if I copy this and paste it into the console, I can now call the DA function with a date, and it should spit out a word back to me. So if I call DA on new date, January, today's date, 21st, 2022, it comes up with prick, which is kind of ironic because some people would consider that this is not a super fun way to honor the game, but I would argue it's a great way to learn some JavaScript. So if I just type this in here, Wordle validates that I am a genius and also a prick. So yeah, so that's all I really wanted to show. You can put in any date past the initial date, and it will always give you something within LA. So on the 22nd, the word is going to be wince. There's your spoiler. I won't give you any more. I'll let it up. I'll leave it up to you to play around with this a little bit more if you want to. But something interesting, we talked about that TA array. It's never indexed, but it is used here in this function called evaluate row. Excuse me. So evaluate row sounds like the code that is called whenever you put something in and hit enter. And what this says is if the word you enter is not included in TA and it is not included in LA, it throws some kind of weird error saying that that is not a valid word. And that makes sense because in the rules of the game, we aren't allowed to ever enter a 5-letter word, a valid 5-letter word into the game. So TA represents all of the valid 5-letter words that you can enter, but you will never be able to guess a word from the list TA. So all of your words will always be in LA. So yeah, if the website never changes, this is how it works. And if it does change, this is a cool opportunity to learn a little bit about how websites get their behavior. So thanks for watching. See you later.